Welcome everyone to the KappaOne Sentinel-1 data layers for the subsidy checks under the Common Agriculture Policy webinar. I'm going to introduce you to the topic in the following hour, and then we will have a questions and answer round. And I will, of course, start with a little introduction to the topic, talk about the Sentinel-1 and SAR data, and then I will try to explain what is exactly KappaOne. And the main part of the webinar is, of course, getting through some real-life examples of how could KappaOne be helpful with the subsidy checks under the Common Agriculture Policy. So why we decided to actually work with Sentinel-1? Mainly because it's a radar satellite, but it produces data both day and night, and it can also, so to say, see through clouds, or the clouds don't bother the Sentinel-1. And this means that we get a really dense temporal resolution. And therefore, it's a great source of data for monitoring different changes in land, and especially in agricultural land. The only problem with the Sentinel-1 SAR data is that the pre-processing can be quite complex, and therefore it is not as widely used as, for example, the Sentinel-2 optical data. So we decided to kind of take the best out of Sentinel-1 and make it really easily accessible for people, so they can skip those complex pre-processing steps and just use it. So in short, KappaOne is easily accessible and ready to be used and analyzed Sentinel-1 SAR data. And it consists of 4 different Sentinel-1 products. It's backscatter, both VH and VV polarization, and coherence, also VV and VH polarization. And moreover, there are 2 composite products, more like false color images. I will show it in a short. And we also have 1 custom product, which I will also introduce to you. About all these parts, I will have specific slides to explain. But KappaOne can be accessed in 3 different ways. First of all, it's a web map, which I will be mainly showing today to introduce to you. But the layers in the web map can also be opened in different GIS software using web map service. And I will show you a short introduction to that using QGIS. And the third way is also to directly access some data via API. And when I mentioned that we try to make the complexity of the pre-processing of SAR data something that not bothers the people, the main idea behind it is that we do professional calibration and of course the thermal noise correction and the speckle suppression, which makes the radar data kind of just understandable to a human eye and also understandable to the machine. So if you want to use it for machine learning purposes. And that was the short introduction to KappaOne. And next, this is the web map I mentioned before. It's we have 2 demos in 2 different countries in Europe. One is in Estonia, and Another one is about Germany, and I will be showing you the Germany demo. But it's quite simple. You can, of course, start with choosing one of the layers and go back and forth in time. For the German demo, we have data from 2020 until a couple days ago, so we have really fresh data to show you. And you can also download the QGIS project or just get the WMS link to open in different GIS software. And for this demo, we also have some parcel geometries. I hope you can see them, but by clicking on the parcel geometry, there's also an option to view the time series. And they look like this. So there is one, the green line is Sentinel-2 NDVI, and the blue line is the VH polarization coherence from Sentinel-1. And also by clicking on the Sentinel-2 data point, you can open the true color image from that date. And it's also possible to go back and forth where the data for Sentinel-2 is available, of course. But I will show you how it works in the demo just in a bit. But first, I wanted to explain what are the layers that we have in KappaOne. And I wanted to start with the coherence, which is a grayscale image, which basically shows the change between two Sentinel-1 images taken. So when we had two satellites, Sentinel-1A and Sentinel-1B, the time frame, the period was 6 days. So the coherence image showed the change that happened during the 6 days. And now with only Sentinel-1A, we have the 12-day period. And coherence image is great actually for detection of landscape changes and also the amount of vegetation cover. And the rule of thumb to look at the coherence images is that all the dark gray areas mean that something has changed through this 6-day or 12-day period. And the light gray or even white areas mean that nothing has changed, so the area stayed the same. And all the forests and croplands was actually like crops growing or grasses. They usually look dark gray. But if, for example, it's early spring and the field was plowed, it's just a bare soil and it will appear really bright light gray. Next, we have VV backscatter, which shows the intensity of the radar reflection. And it's great for detection of the presence of vegetation and buildings. And here, all the areas which have some amount of vegetation or buildings look bright light gray, and the more vegetation, the higher buildings are, the brighter backscatter shows. And if it's a water body or just a bare land, it's usually dark gray. And the water bodies usually look just black. Also, in case of, for example, flooded fields, they usually look almost the same as the water bodies. Then we also have the VV polarization coherence composite image. It's a false color image where the red channel is VV backscatter, green channel is VH backscatter, and blue channel is VV coherence. And it's really bright. It has lots of colors. And it takes a bit time to kind of get used to it and start seeing things. But the main colors, for example, the green one, actually means the vegetation. So green parts can be forests or fields with the higher amount of vegetation, the brighter the look. And the purple pinkish areas are usually with really low vegetation cover or just bare lands. And you can see how like different they can be. For example, these fields have just many different colors, but it's definitely going to become brighter as the vegetation cover grows. Right. And here also we don't have any. I think maybe this small one here is some water body. The water bodies also appear really dark blue or even black on these images. And then we have another composite image where which is only backscatter, but in red channel we have some of VH and VV polarization. Green one is VH and blue is VV backscatter. And this, comparing to the previous one, may seem a bit more like friendly to an eye. The colors are more subtle, but here also different types of green, like this really bright green and the dark green, indicate fields, just different crop types. The brighter green is the higher biomass crops are growing, and this like light, a bit purplish or white greens are usually forests, and the purple areas are the bare lands. And the water bodies and flooded areas appear really dark. And this is the custom product we have. It's synthetic NTVI. It takes the historical time series of both Sentinel-1 and Sentinel-2 and creates kind of like imitation of the usual, the common NTVI that we have from Sentinel-2, but because the temporal resolution of Sentinel-1 is more dense, then we have these kind of images almost definitely like every week, or even more, like 2 or 3 times a week. And here it's the interpretation of these images is the same as the Sentinel-2 NTVI. The darker the green is, the higher biomass there is, and the red land indicates some bare soil or like almost no vegetation. And now I wanted to first, before we'll go to some specific examples, I just wanted to show you around in the web map. Here's the landing page for KappaOne, and we will click on Explore Demo. And as I showed you before, here you can choose one of the layers to be visible. You can also just have the OpenStreetMap to compare. But we will maybe choose the backscatter composite. And can you also choose the date of the image? You can go to 2021 or 2022, but let's just stay in. The latest one is from 2 days ago. It's 28th of June. And right, here if we zoom in, we have parcel geometries, and if you click on the parcel geometry, you can also view the chart. But the chart here is actually about the 2021, just because we wanted to show the whole vegetative season. So it's from 2021 April until until the end of the year. and can also jump into one of the true color images and see how the field changed. So let's take one of the examples. First one is crop type classification. And for this, I think we can stay in this composite image. And as I mentioned before, in all the green areas indicate vegetation cover. And zoom in, we can see that there's the shape of the field, which is really, really bright green. And there is, next to it is like a dark green. And usually the light green one mean that there is a crop with really high biomass. So it could be rapeseed growing there, or maize, or something similar. And in case of really dark green fields, it's usually some kind of cereal, for example, wheat or rye, or it can also be a grassland. And maybe to show some time series to confirm it, we can go into last year. Maybe also in May. Yes, there's some different crops growing last year. So, for example, here, we can go further. Right. So we have some really dark green and really bright green fields. We can, for example, click on this one and check from the time series. So we were at beginning of June. Let's start from May and see how it developed. May. So yes, it started blooming in the end of May, and it's definitely rapeseed. And you can see it from here too. But if we take, for example, this dark green one, it has a different, sorry, maybe I'm too quick, but it has a different signature. And if we look at the images, right, there is no blooming. It's probably some kind of wheat, some cereal growing, and only at some point in July it starts reaping it. And again, in case of this really bright purple ones, it means that it's a bare field right now, so we don't know if it's going to be what kind of crop is going to grow there. And the next example is harvesting detection. For this, I think we can switch to coherence. And for harvesting, usually happens later in the season, so maybe sometime from the end of July, maybe even in August. It's a lot. Maybe if we just go, yes, for example, here, we can see that coherence dark gray indicates that there is a lot of change happening. And in case of the crops, it's usually that the crops are growing and the wind is blowing, and just the direction of the leaves is never the same. So on coherence images, the land covered with vegetation usually is dark gray because everything is changing. But if the crop is harvested, yes, it can turn light gray in this case, like this. Maybe we can have some other example also. For example, here too, it's beginning of August, which is usually the time for rapeseed harvesting. And here's also turns really bright. Let's take another example. Next one is mowing detection. For this, we maybe want to switch to the composite layer first to find some grasslands. It should look in June. And all the light green ones are probably the high biomass, so that's not what we're looking for, but we're looking for some dark green parcels. A lot of dark green ones here. Right, so maybe we can now switch to coherence and check some of these parcels. And now they're all dark, no change. Nothing changes for a bit for the whole July. Okay, more. Maybe in September. Mowing usually happens, starting from July until October. Yes, for example, we can zoom in here so you can see. For example, this one, small parcel, you can check if it's, yes, it's probably grassland. This looks like it. And in the beginning of September, there is a, you can see that it becomes really bright. So we can check it from the chart also. So here, yes, it's still green, but yes, it was mown sometime in the beginning of September. And it's great that we have the Sentinel-2 images to check it, but it's not always like that. Coherence images are really suitable for mowing detection. Let's go on. And something that we can try to check even from current year, so we should go back to 2022, is some ploughing events, which could have happened in early spring. Switch to 12 coherence and go in the late March. And for this, maybe we can look at the coherence composite image, right? There is a lot of bare areas. All the blue area indicate that there is nothing much on the growing yet. But we can, yes, on this composite image, the really bright red color usually indicates that ploughing has happened just recently. If we go one image back, yes, there's it's just bare land, but it's ploughing, the soil has been turned into, we can see really bright red. And if we go on, as it kind of fades away, and the red eventually becomes more pink, and pink means that it's still bare soil, but it's not. It has been plowed in a while. And here's also some new area that has been plowed recently. And then it fades away. And something else that I wanted to show you, that if we just zoom out and just look at the whole image at the same time, we can see that in April, it's lots of purple, blue areas, which of course indicates that there is not much vegetation growing yet. But if we just rapidly switch to, for example, 25th of June, yeah, it looks completely different. Everything has at least some amount of vegetation. There is only really tiny parts which are still purple or blue, which has no vegetation cover on it. And everything more or less started growing. And there is also one airfield, I believe, which just stays bare. The next example is flood detection on some coastal pastures. And for this, actually, I think we will switch to backscatter images, because they, yeah, if there is a water body, it shows it really dark gray or black. So we can go at some coastal areas here. And some parcels. And maybe go to March and check if there has been some. Yes, you can see that the water body from this right side and the sea from the left side, they're really dark, almost black. And there are some areas on these fields that are also looking really dark. But this is kind of changing, becoming small time. We can check it also on the composite. Yes, here it also looks really almost the same color as the water body next to it. Yes, and just in a couple of days, you can see that the amount of water actually decreased, because it doesn't look as dark anymore. And yes, I think that's the last example I'm going to show you. Detection of some non-homogeneous areas. With this, we can switch to 6 coherence and go to last year vegetation season, into June, and switch to this. For example, yes, this is here one of the parcels that I believe that there is 2 different crop types growing, and we can see how it evolves through time. There's just strip of something different happening on this field. And yeah, it's one of the crops is kind of more biomass, and the other one can be just maybe grassland where animals are grazing. And yeah, it's just stays the same period. I think you can also see it from a different composite, but yes, we can find some other things like that. Let's see. this seems also like it's divided into two parts. We can also check it from the true color image. It says sometime in July. Yes, there's probably something different happening on one parcel. One more example, which is actually from the Estonian demo, is it's also some parcels can be overgrown by some weeds or bushes, and this is also visible from the composite image. And here is the orthophoto to confirm this example. And one more thing that I wanted to show you is actually how to open KappaOne using WMS. For this, you can either copy the link, or you can also just download the QGIS project, which we're going to do now. And I already have the QGIS open, but right. I will show you how this process. You can go to layer, and to open this project, you should click on the select layers and groups to embed, and just find this layer that you downloaded, and then it will appear in the QGIS. And one thing that we are developing is actually a way to not only have this one raster that you have downloaded, but actually also go into back and forth time. And for this, it's only available in the latest QGIS versions. But here is this temporal controller panel. If you click on it, you can actually for this, you can access actually all the dates that we have in the web map, and you can just go back and forth and see all the rasters that are available in the web map. And have a layer of the same parcels that we had in the. Change it to right. Make it more. Now it's more visible. This is great because in QGIS you can add your own partial geometries and look at the specific fields you're interested in, and also see how they change in time. So we can just jump from example. Right now we're in end of. I can go to beginning of June. Yes, so we can also see how the parcel actually looks just 1 year after that. So here there's probably some serial growing, but if we go to 2021, yeah, it's actually a different crop. It's probably rapeseed growing here. And I also have, I think, another layer to show you. Yes, the different composite image. It's also a high BMS crop. Yes, and for QGIS, we actually are really open to any kind of feedback we could have. What can else we do to make this more usable, and what kind of other options could be here? Very important. That's it. yeah, of course, if you just close this temporal controller panel, the raster can be used just as rasters. Just take some time. So, right. And that's actually it. I hope you have some questions. I'm really looking forward to answer those. And as I said before, we are still in the process of development of the KappaOne, and we are looking forward to any kind of feedback you could provide us. Thank you.